Having me and Randy. We are going to tag team this presentation a little bit today. How do you stuff 23 years of lessons learned into 15-minute presentation? It looks like we're ahead of schedule, so I'm good to go for 45. Okay, cool. So we are all here in this room because we are passionate about what we do. We're passionate about a legacy, leaving a legacy. And so I want to leave you with that. If you're just getting started in the conservation world, it can be discouraging at times. When you see you planted 2,000 plants and you get 150 to survive, that can be discouraging. But I think it was said earlier, keep moving forward. So we're going to keep moving forward. I don't have a presentation up here yet, so I'll just keep talking. So Hangman Creek is what I'm going to be talking about. I titled this presentation, Hangman Creek Case Study, Streambank Stabilization, and Riparian Restoration in a Volatile System. A lot of you guys probably work in volatile systems where everything out there, it seems, is trying to either kill your plants or tear your project apart, and it's an uphill battle at times. So Randy's going to be presenting a little bit more on the riparian restoration side of things, and so I'll be presenting a little bit more on the streambank stabilization side of things. So Hangman Creek, if you're not familiar with it, is in Spokane, primarily in Spokane County. It's also in North Idaho and runs through the corner of Whitman County there, and it's got a couple of unique features. Geologically, you've got Populus lust soils, which are highly erodible in the upper part of the basin in Spokane County. And then in the middle section, you've got a lot of canyon section, rock, a lot of basalt area. And then in the lower, you got Missoula flood deposits, which those are a geological sediment contribution, which we don't really tackle that a lot. You got these high banks, and so we're primarily doing toe stabilization in those areas. But what I'm going to be talking about is mostly that Populus upper section that we're working on, the Populus soil section. So just a couple things I wanted to point out on this list of factors to volatility. It is a very flashy hydrology with a range of upwards of 20,000 CFS all the way down to 1 CFS during low critical flow periods. And so that's a very challenging system to work in. And then it's got a lot of issues with heavy agricultural use. So land use and habitat impacts because of those land uses, historic and ongoing. And so one of the primary factors contributing to the flashiness of the Hangman Creek Basin was the agricultural use. And there were early programs, U.S. Food to Freedom programs in the 30s, from the 30s through the 50s during World War II, that encouraged manipulation of the stream. And so this is a quote from Everett Anderson, who worked for Agricultural Soil Conservation Service, which was a predecessor to NRCS. We straightened 3 miles of Hangman from the bridge in Tensett all the way to the state line, about 3 miles or so. We moved a lot of earth and filled it in the old meanders. We finished, and there was another 300 acres of the best soil in Benoit County. It was a beautiful project. And so I want to leave you with that. That's over the past 100 years, there's been a lot of manipulation, not only in Hangman Creek, but a lot of these systems. And so that flashiness lends itself to high flood events. This is actually a picture of the 20,000 CFS event that occurred in 1997 on Hangman Creek. And that was the peak flow, recorded flow for that watershed. One of the other factors contributing to erosion issues in Hangman are ice flows. So we get a lot of early season runoff events, which are carrying big rafts of ice. And so that lends itself to undercutting. And it's the moderate flows actually that do a lot of the erosive forces in Hangman, where it's undercutting that bank, then the bank collapses on itself after the flows recede, and then the process repeats itself. So this site was one of our restoration sites. It's approximately river mile 17 from the Spokane River. And so in February of 2017, we had a 10,000 CFS runoff event, which we actually had a design done for this site. And once that runoff event occurred, I called the engineer. I said, hey, we need to quantify what the damages were here, because this bank right here actually was straight across to where that dog is standing. So we quantified approximately 16,000 tons of Streambank material were mobilized in that one event just from this site. And that's occurring up and down that system. And so this is the result. You get chocolate milk flows into the Spokane River. That's the mouth of Hangman Creek into the Spokane River. And then it piles up behind 9 Mile Dam on Long Lake. Hang on. So that whole area right there, all of this is primarily Hangman Creek sediments that have accumulated above 9 Mile Dam over the last about 100 years. And so they're constantly dredging this area here for maintenance. And there's been modifications to the dam to deal with this issue. And so I just want to reiterate, in most cases, you need to stabilize those banks before you can plant onto them. It's really difficult to just plant on the top of a cut bank like this and expect those trees to survive when it's getting undercut and collapsing on itself. All your plantings end up in the creek anyway. So this is an example of a stabilization on a tributary to Hangman Creek on Rock Creek. So we start with stabilization and then move into riparian restoration. So this is that same site I mentioned with the 16,000 tons of material that were mobilized. We went in, did a redesign, and there is a lot of good sinuosity in this reach, but we had a severe cut bank right here. This was a cut bank, about 8 to 10 foot cut, and over here as well. There's about 3,200 feet of stream bank or stabilization that occurred with this part of the project. This was called phase 1, and we had the landowners upstream here. There's some cut banks right here. They saw what we were doing, contacted us when we completed this project, said we want to do something similar. So the snowball effect on that one. And so this is that bank that you saw from the air there on River Mile 17, phase 1. This rock elevation is approximately the height of a 2-year interval flood event where you would expect to see those ice chunks running along and eroding that bank. So it does have some toe stabilization with rock. We usually try to avoid that, but in a lot of cases in this system, you just can't avoid having a little bit of rock in there. And then I was educated today on the evils of coconut fiber fabric. So again, after 23 years, I've learned something today, but I have not yet found a good stabilization medium that compares to coconut fabric, so we do utilize it in our projects. This is a woody revetment bank on the same project area. We also incorporated a lot of willows into the build out of that woody revetment bank. Root wads, these were actually a lot of smaller root wad installations this came out of a burn area, so that was a good way to source that material, and the contractor provided it. So this is that same picture I showed you earlier, and that's the site when we were completed in July of 2019. Again, coconut fiber logs were utilized in this. This is phase 2 of that project. Those downstream cut banks that I was showing you earlier. These are 16-inch diameter coir logs that were incorporated in a soil encapsulated lifts for this particular section of bank. A lot of wedge stakes to hold that erosion fabric down. Again, the bank where the coconut logs the soil lifts were implemented, we also installed wood at the toe, incorporated with some rock around it to hold it all together. No cabling was done on this one. And then live plant cuttings were installed with the large woody debris. This is the upstream section of that bank. We also, during construction, not a really ideal time of year to plant, but it was mid-July and we were putting plants in because we had the machine equipment there to dig the hole for us, so that saved us on some labor. But this is the backside of a soil lift before we're filling it, so that fabric's keyed in right along the backside, the 16-inch coir log staked down, and then we backfill with material. Sorry. And then roll that fabric back over. That's lift one on that. We incorporated plantings between each lift. That's that bank at the finish. And this had a high bluff, and so this was reshaped. This whole slope was reshaped at a 4-to-1 slope, or actually, excuse me, 2-to-1 slope, seeded and mulched, and then planted. So this was our most recent project. This was completed in 2023. This is a tributary to Hangman Creek in the upper watershed near Tico. It's actually in Whitman County. This was a cooperative project between the Pine Creek Conservation District and the Spokane Conservation District. Again, this segment of the creek, or this tributary, particular segment was about almost a mile of ownership. So. And it would have been manipulated by that landowner previously. And so the design on this one was a 2-stage channel with remeandering to create a 100-foot wide stream corridor. The corridor excavation was approximately 3,400 cubic yards. That's 3,040 standard dump truck loads. So a lot of dirt moving. I think I had probably 2 cubic yards on my face that day. And so this is an example of remeandering, building the new channel segment. We actually increased the sinuosity, so the stream length increased by almost 200 feet with this project. I am sorry about that. And so that rebuilt the banks back. You're talking about reed canary grass suppression. We actually utilized the reed canary grass to build these banks back because we knew we weren't going to fight it. And then it's wrapped with coconut fiber. So this is that bank construction. And that's a real good look, aerial photo look to give you the scope and scale of this project. That right there is about halfway through the project area. So like I said, almost a mile of stream work. So that's a look from the other angle. This is about halfway through the project area. A shout out to Plants of the Wild. We do source a lot of our plants from different nurseries. We utilize a lot of plants from Plants of the Wild as well, who's a sponsor here. Irrigation is always an important component to a lot of our projects. This is a 8-zone irrigation system I was involved in installing at that site, at the Little Hangman site. We actually placed the drip irrigation in the root zone on the toe of this, the floodplain bank or floodplain bench, and then put our plantings in, rolled that dirt rack over top of the drip irrigation. And it's Randy's turn. We'll answer some questions at the end. Thank you. What am I doing here? So forward, back, laser.
Got it. All right, so I think I got about 5 or 7 minutes somewhere in there, but
8 minutes and 46 seconds.
oh,
Ooh,
plenty
you
of
can
time
do it.
in, I think. I mostly want to present this more as a potential for learning lessons. This is probably the biggest single program the Conservation District, Spokane Conservation District, has taken over. So this is the Riparian Conservation and Restoration Program pilot, and it's put on by Department of Ecology. We're the ones implementing it. Currently, we're sitting at $5 million in funding to make this all happen. We have about 300 acres that are in contract or about to be in contract for riparian buffers. A lot of the landowners we're working with in this case, this is a case of we'll take what we can get kind of situations. So Dan just talked a lot about stream bank restoration as far as actually stabilizing the bank before you're planting into it, but we can't do that in a lot of these cases. So some of these are the ones that we have stabilized the bank, but a lot of them are just, we got a buffer, let's get some plants in the ground. And in a lot of cases, that is the best solution because it's the only solution. So these landowners or the operators or however they decide to split it themselves are getting $300 an acre for tillage practices, $200 an acre for grazing practices to convert over to a buffer system. So yeah, administered by the Spokane Conservation District, any stream type is eligible. I say there's 300 acres in there, about 120 of those acres are headwater, and the rest are mainly along the main stem of Hangman Creek. So it doesn't matter where it's at, it's eligible if there's erosion visible and ecology deems it a place of potential. So the buffer sizes are based, it's switched off and on, but they're based usually and currently on bank full width. In the past, they were also site potential tree height, but that really just depends on whether it's ephemeral, intermittent, or perennial. So you can see here, we've already talked about the single weed mat per plant. Probably not ideal. It's what we're currently working with. And I am extremely open to any other ideas. If you guys have an idea that you want to implement, or maybe you don't have it's not feasible for you, I would like to hear about it so we can start playing with these 300 acres and see what works here. Hand irrigation has been an absolute necessity. We're currently sitting at a mortality or a survival rate of about 80% on our first year plantings. So we're watering by hand. We got a water truck. We're pumping out of the creek if we have to. But on top of that, we're looking at just access to a lot of these sites is very limited. I don't know if you can quite see it, but we've got a little aluminum boat. That's our little canopy on the other side for part of our crew to get to. We're crossing the creek in as creative ways as we can come up with to make this happen on a lot of these properties. You can't really see it, but the closest access here is about 2 miles of farmland. So, and it's all in crop. So we do not have access to that side of the creek. So yeah, we've gotten creative. We've made log plank bridges to get across in some places, but anything we can to get plants on the ground and water to them. The other thing we're implementing going forward, our first year was kind of rushed. We had to plant in before or as we were seeding these properties, but we are planting grass on these properties prior to doing anything else, especially in the commodity conversion portions. So in those cases, we'll get the grass seed on the ground, whether it's us actually sowing it or the operator that's or the landowner on those properties. But we will look at 1 to 3 years of grass establishment, and that's weed management as well, in order to get that to a point where we can plant woody plant material into it. Our first year of implementation, we got 22,000 plants in the ground, and we converted 87 acres of commodity to grass buffer. The other big problem with not creating a stabilized bank or creating those ideal toes is we're working with a completely incised channel. We have essentially 2 planting zones here. We're planting into the toe and we're planting upland. So there's not a lot to work with without changing the channel dynamics. So here we've got 2 pictures of just our grass stand establishing at different property sites. We are utilizing other entities. So we're using the Lands Council is one of those entities that is bringing in volunteers. They will likely actually contract work for us in the future for some of these sites just to handle the workload. We're at 300 acres, but just this year we've got probably another 70 that we'll end up putting into contract. This is actually the site that Dan was just talking about, where they did the core wrap, stabilization, re-meandered the channel, basically recreated the creek. But this is us this year coming back out and planting in some willows. One of the big problems with that site that we came across was We weren't expecting beavers. We haven't seen beavers here before, and we now have beavers. You build it, they come. Here we are. Luckily, it's a big site, so they didn't get to all of it, but they got quite a bit, and we're pretty much replanting all the willows on that section. And in some cases, we're just leaving that section alone, and they can have it. So that's all I've got. Hopefully, in 5 years' time, I can come back and I can tell you guys what worked, what didn't work, and see where it's at.
Just a side note, this is my favorite GoPro capture. See the bumblebee?
And that's River Mile 17, isn't it?
River Mile 17, phase 2. So another site that we worked on, or I did a project on, or managed a project on, in the Little Spokane watershed. It's in the north part of Spokane County, and it's actually not. It's a little bit more easy to work on in that system, but there was a straightened segment of Bear Creek, a tributary to Little Spokane, that we re-meandered, and we actually, it was reed canary grass infested. We flipped the sod, so we marked out our new stream section and cut from the center of that and flipped the sod back over on itself, and then went back in and planted native vegetation, alder, willow, and got a really good stand of alder and willow to come up and get established. And once it started shading that out, we started winning the battle there. So but that flip sod stabilized those banks. And we did not use any coconut fiber on that one. So that makes sense. Yeah, it actually raised, I mean, that reed canary grass rhizome mat was about 10 inches thick. So when we had the existing elevation, we got about a 10-inch lift when we flipped that sod, which gave us stable banks to work from.
Yeah, so on a lot of our buffers too, we're not doing a whole lot as far as reed canary control. It's pretty much mowing, scalping where we're actually planting, and we're kind of just hoping on that. Keeping it mowed down, we'll let the other things establish, shade it out eventually, and we can just get more biodiversity in there without having to eliminate it.
And as Randy kind of alluded to earlier, we'd like to do some experimentation with the Riparian pilot program, do some cardboard and some wood fiber areas and work around that. Just so if there's some ideas, I mean, it's great to come to something like this and just, because sometimes you get so project focused, you don't really, realize that there's other methods that are being tried, and it's worth some experimentation.
You can go on positive, the way it changed the channel.
The positive, I mean, it could be considered or looked at as a negative if you're looking at, oh, well, it changed the channel location for that segment of the project. But what it actually ended up doing, it really just increased the water table for the plantings in that area upstream, because he did build a dam, but it got washed out in the spring runoff event. But we don't see a quantitative, oh, these plants did much better in this section above the beaver dam, but you can see that the water table is a little bit higher up there.
The beaver did take out a lot of our plants, and actually one of our attempts to curb it was we had willow whips that we just didn't get in the ground on time and they were dry. So we set them out as decoys and they used that to build the dam instead of taking out a bunch of our trees. Still lost a lot of them, but
Still make the switch.
Perfect, I was just gonna ask you, would you consider bringing truckloads of aspen, cottonwood, and willow and just dumping into the beavers?
it's on our list to try.
Yeah,
Yes.
we've had conversations. I mean, over the years, I've actually noted that western red cedar is a preferred species by deer, and so I'll plant those as decoys and they leave all that.
Time for one more question? Right in the back? Yeah, so the little hangman, that was actually
Melissa?
Yes.
Hey!
I know you talked about the reason why that site.
Essentially, we did. We just there was a higher energy component there, and so we basically faced that with the coir fabric because of the concern by the engineer that it was going to get eroded if we didn't do that. Just a side note, also, I mean, we also seeded the beavers out of that whole site on top of the coir fabric and underneath, and then we did a bunch of sedge and brush plugs. So the planting was fairly extensive. We got a lot of sediment, actually aggradation at the site, and so we lost some planting just because it started depositing sediment through there. I've only seen positives so far. Yeah, and like I said, you want to get that native vegetation in there, shading it out or suppressing it.